Welcome to the Precipitation Reactions experiment. There's a few key concepts: double displacement reactions, precipitation reactions, a subset of those. We're going to need some solubility rules, and finally we're going to write ionic equations for some of these. But first, let's set up the experiment and let's do it. You're going to need a number of items shown here, and a reaction grid. This particular reaction grid has been cleaned and a final rinse with DI water. We're going to have 10 reagents that we're going to use, and the first thing we're going to do is use a well plate. We're going to get us a small stash of each of those for use later. First chemical is put in well number A1, and then the next in A2, and so on until we have samples of each of the 10 reagents we're going to use. Now we're going to put drops of each of those on that reaction grid, but to do it we need a very, very small drop, and so we're going to use what's called a pull pipette. We have stretched the pipette, and then with scissors, about a ½ inch or so below where it first thinned out, we make a 45-degree cut. We will do that for 10 separate pipettes, given we have 10 reagents we're going to use. And so we don't get them confused, we're going to label each of those 10 pipettes. After that, it's pretty easy to figure out what we're going to do. With each of those 10 chemicals that we have, we are going to pull the chemical up into the respective pipettes. Next, it's time to spot the reaction grid with each of those chemicals. As you can see on the reaction grid, 5 of our reagents are across the top, and 5 are listed down the side. So we're going to have a matrix of 25 mixtures that we're going to make. First thing we're going to do is spot the columns. You just saw the sodium chloride column get spotted, and we're going to repeat the process for each of the next 5 reagents shown across the top of the reaction grid. If you want to get a better view, you have a copy of the reaction grid in your lab manual. At this point, we have no reaction. Each spot just has one particular reagent on it. The reaction will occur when we add a second reagent, those shown to the left side, when we spot each row. But before we do that, we had a few stray drops. We'll clean those up. The dot has a white half and a black half. We are looking for precipitate or cloudiness. If it's a dark precipitate, then it will show up better on the white or light side of the circle. And if it's a light colored precipitate, it will show up better looking at it through the dark side of the circle. Now to spot across with silver nitrate. You could see there was a lot of color change there. Some of the reactions are more obvious than others, and of course some of these there will be no reaction at all. Spotting across with lead acetate, and now sodium nitrate. Notice that we spotted down the columns, and once we spot across the rows, each dot now will have 2 chemicals on it, and they may or may not react. That's what you will determine from your observation. Finally, the barium chloride row. And let's have a look at the close-up of what those look like. Feel free to pause the video and make your observations as you go. Let's have a closer look at each of those rows, starting with what we'll call the silver nitrate row. Silver nitrate with sodium chloride, sodium nitrate, sodium carbonate, potassium chromate, and sodium hydroxide. And the lead acetate row with sodium chloride, sodium sulfate, sodium carbonate, potassium chromate, and sodium hydroxide. Sodium nitrate mixed with sodium chloride, sodium sulfate, sodium carbonate, chromate, and sodium hydroxide. Copper sulfate added with sodium chloride, sodium sulfate, sodium chromate, potassium chromate, and sodium hydroxide. And the last row is barium chloride reacted with the same 5 reagents, which are sodium chloride, sodium sulfate, sodium carbonate, potassium chromate, and finally sodium hydroxide. And there's your 25 reactions. Next, you'll write the molecular equations for the reactions, which had a precipitate or showed evidence of a precipitate, such as cloudiness or haziness. For each of the reactions, each of the 25 that you did, you write the reactants on the left-hand side and a right arrow. Then, if you observed a precipitate or haziness, you will write the products on the right-hand side, and then you will make sure each of those products is charge neutral. And then you balance the chemical equation. And finally, you're going to circle the material which caused the haziness or the precipitation. If there's no reaction, you'll still draw the reactants in the right-hand arrow, but end it with an NR for no reaction. Perchance you need a refresher on writing double displacement reactions, go to the Intro Chem Exam 2 playlist and scroll down to video 7.03 double displacement and precipitation reactions. And for those reactions for which a precipitate was observed, you will need to write the net ionic reaction, which is part B. To do that, you're just going to show as a product the material that precipitated, and as a reactant the ions that produced that precipitate. These equations too should be balanced. You will only have somewhere from 14 to 16 of these because you should have only seen somewhere from 14 to 16 of the reactions in step A actually produced a precipitate. And as with the molecular equations, if you're having trouble remembering how to write a net ionic equation, be sure to refer back to the video 7.03 referred to a few minutes ago. And with that, thanks again for watching.